Okay. Hello, everybody. We're gonna do a just go over the study guide. I'm gonna try to get the study a little bit bigger. And I'll just kind of walk through the problems that are on here. And the first problem is talking about Gloria, the grasshopper, and it's hopping. So that's making me think of a parabolic shape. And just when I draw my model, I'm gonna draw it that the best jump is 28 inches in or centimeters in length. So I put that along the x-axis. Height is my y, and she reaches a height of 20 centimeters. The first thing I do is kind of look for the axis of symmetry. It's halfway, so 14. So my vertex is 14 comma 20. I chose to write mine in vertex form. If you wrote it in intercept form, the intercepts would have been like 0, 0, and 28, 0. So it would have been like the equation would have been x and then x minus 28. But I just did it this way. So when I write it out, y equals a, x minus 14 squared plus 20. Then I chose to substitute in the point 0, 0, have 0 equals a, 0 minus 14 squared plus 20. And then I start simplifying. I solve for a, and I get that a equals negative 20 over 196, which is negative 1.2. You notice here as I'm reading over this that I forgot my negative. So then I make sure that that's a negative on it. So for the second problem, I have an upward facing parabola, so I have positive and a vertex at negative 4, 3. So the negative 4, it's the opposite here. So the opposite of negative 4 is positive 4, and I have x plus 4 squared plus 3. That makes that parabolic. And that the x coordinate there of the vertex is the line of symmetry. Um, so the next one to write, to make it go downward facing, I make a negative. To compress it vertically, compressing means it's going to make it smaller. So I used a number smaller than one for my, or smaller. Here it's definitely smaller than one because it's negative, but it's also in between 0 and 1 right there. So I have that 1/2. And this stayed the same, line of symmetry is the same. So now when I move it to the right, this is really, I'm going to be subtracting the x coordinate by 7. And when I say the x coordinate, it's going to go right here, right where the vertex is. And so I'm going to put a -7, and it's going to move down 3. When I shift this from 4, if I move 7 from negative 4, right? So 4 and that -7 comes to -3. And hopefully that makes sense that if I go from negative 4, I walk that 3 over, and then my new value is there at positive 3. That's where the line of symmetry is. I'm just going to try that one more time. I'm going to rewrite this. This is x equals 3. And when it shifted up 3, that meant that I ended up with my k value is just 0. Okay, for a parent function, I wanted a stretch factor of negative or of 0.25. It's negative because it's downward. And I go shifted 12 units down, -12, and 3 units to the left. Left is a +3. That's what moves it to the left. And then that's my function. I have a cubic function, so I'm going to have this cubed. A stretch factor of 2, a locator point of -6, which inside the parentheses I do the opposite is +6, and then +1. So for this next one, I'm looking for parabolas for x and y intercepts, and then the graph. Always I try to factor it, and this becomes x plus 6, x plus 2. So my intercepts are -6 and -2, and I can graph that. To find the y-intercept, if I plug in 0, this would be 0, and I just get 12. So 0, 12 is my y-intercept. And I did the vertex just because I was here and I wanted to know where it was. This next one does not factor. If If I have like negative three and positive three, that does not come out negative six. And negative one or negative nine and one don't work, and none of those combinations would work. So when I use the quadratic formula, I get my two roots as negative 1.24 and positive 7.24. So those two are there. This one kind of goes off the graph. My y-intercept, if I plug in 0 here, 0, negative 9 is my y-intercept. And the vertex is going to be somewhere way down here off the graph. And I don't need to worry about it too much though. Because I have kind of the general shape. I don't know exactly how far it goes down, but it's going to loop up like that. This one, I don't have to do much work. I have 4 and negative 2. So I have 4 and negative 2. And then when I plug in 0, here's 0, 0, I get negative 4 times 2, which is negative 8. That's my y-intercept, and it's just off the graph there. And there's my graph. For these next problems, I started doing them, and then I had to go on to another sheet because I kind of went off the page because I needed lots of space. For solving, I am just going to start simplifying. I can see that I can isolate this whole squared thing, which means I'm going to be able to square root both sides. So I subtract 8 from both sides. 2y minus 1's quantity squared equals 72, divide by 2. And I get this y minus 1 quantity squared equals 36. So I square root that and I get y minus 1 equals plus or minus 6. When I do a square root, I have to make sure I do two options, the positive and the negative. Y minus 1 equals 6, which when I solve, I get y equals 7. Y minus 1 equals negative 6, which when I solve, I get y equals negative 5. For this one, I decided to factor. This isn't the only way to do that, but I did x minus 5x plus 5. So this is a difference of square patterns. So I get x equals 5, x equals negative 5. For this one, I made a 0, subtracted 6x from both sides, and I got 6x squared minus 6x minus 36 equals 0. And then 6 quantity x squared minus x minus 6. I factored out a 6. And then I factored this quadratic inside. So I get 6 and then x minus 3, quantity x minus 3, quantity x plus 2. My two zeros are x equals 3 and x equals negative 2. Here, this is my starting cost in an exponential. I put that in there first. And then I have 4% is the same as 0.04. And when I have an increase, I actually am taking 100% and then adding that 4%. So the same thing here, 100% is the number 1 plus 0.04, which is where I got that multiplier. When I do 3.84 times 1.04 to the 10th, there's the number I get. And this is kind of a weird problem. It ends up being just a Pythagorean problem. This will not appear on your test, but I'll just go through it. So Sammy has a 10-foot ladder. So the ladder, it's leaning, it's 10 feet. He's trying to go up to the roof of the house. It doesn't go all the way because it's not long enough. So it's going to go up somewhere on the house. And I'm looking for the distance in between. So the first thing I'm going to do, it has to be 1.5 on there. I have two known sides, which just means Pythagorean theorem. So 10 squared plus x squared equals 1.5 squared. I square, I subtract, I square root, and I get that the ladder reaches up 9.88 feet. When I subtract that from 12, I get that it's like 2.12 feet from the roof. On to the next side, we've got some of these good old exponents. I started simplifying I distributed the exponent to the terms inside. 6 squared is 36, x squared just here, x squared, y to the 5th squared is y to the 10th. Now I do the coefficients, the big numbers. 5 times 36 is 180. And then negative x to the negative 4th plus or times x to the 2nd becomes x to the negative 2nd. Y10 is y20. And I wrote my answer. I don't care which way you write it, both are the same. So in this problem, this is a perfect square, a binomial squared. You can make a box or you can distribute twice, or you can know the pattern. What ends up happening is that that this is really twice. So in the box, I would have like 4x squared minus 5y and 4x squared minus 5y. So the first term is squared. 4x squared times 4x squared is 16x to the fourth. That last term is just going to be negative 5y times negative 5y, which comes out positive 25y squared. And then the two terms multiplied, 4x squared times negative 5y, that's going to happen twice. So I get twice the product of the middle terms. And this is my ending product. But you can just work it out in the box and you'll get the same thing. Oh, and this one, I didn't quite finish this one up. So I noticed that 108 and 72 both divide by 36. So this is 3 on the top and 2 on the bottom. I'm going to move all the exponents up to the top, and then I can rewrite with positive exponents if I feel like it. X to the first minus, or it's like divided by x to the negative third. I subtract the exponent, 1 minus negative 3 becomes x to the fourth. Y to the fourth divided by y to the eighth. I subtract the exponents. Y minus 4 is, or sorry, 4 minus 4, 4 minus 8 is negative 4. So I could write this is the correct answer. If I wanted to rewrite it with positive exponents only, I could move that y to the y to the fourth to the bottom. And there's my answer. For this next problem, I had intended to write this as a difference of squares so that it had the same exact terms. One was this binomial was subtracted, this binomial had addition. That pattern, when I multiply it out, I end up with the first term, which is 9x to the sixth. I square this. And then the last term, I square that and I subtract them. That's why this is a difference of squares. A perfect square, I end up with 3 terms. A difference of squares, those terms cancel, and I end up with just 2. If you were to multiply it out the way you'd written, you get this long thing with 4 different terms. 9x to the fourth, 21x to the third, y squared, minus 141x to the third, minus 329y squared. I didn't have room for that. Okay, this problem is asking about the functions. I drew out all the function families just to remember. You should be studying what these look like. You want to be able to kind of like remember these no matter what. Hopefully line and parabola you already have, and we've been working on this one since unit 1 so that you really should have an idea of what these all look like. And decreasing average rate, this means concave down. So D is the function that's concave down of the whole thing. Okay, this one is tricky and it is defined in a piecewise way. Because from between 0 and 4, I've got this $25 a person. So for 3 times 25 is 75, and that's it. 7, I have 4 at that $25 rate, and then 3 at the $18 rate, and I get a total of 154. So for this, I thought it was a little bit strange to ask for the domain. I should just be, so I kind of said that n has to be greater than or equal to 0. So you can't have tickets, and n should really be integers. And technically, this is really natural numbers or whole numbers because it has to be, can't be like partial values. For C of n, I would have 25 times n, just when the people is between 0 and 4. And then after that, if there's 4 people, the additional tickets cost $18. So this looks a little weird because this is $100. That's 25 times 4. Then I have $18 for every person more than 4. So I have to like subtract this n minus 4 to get the people that are paying $18. And then that one is strictly greater than 4. Okay. For this backside, this is half of the function. So here's my function. And remember that x is my input and f of x is my output y. So I took all of the values, the y values, like here I have the negative 1, 4, and I multiplied by a half. And it's just kind of like squishing it a little bit. And then this one was here at 2, and half of that was 1. This was 4 and it went to 2. And so it just kind of like squished it just a tiny bit. This motion, there's two motions, and the negative happens first because there's no parentheses. If it had been like parentheses plus 3, the negative outside, then I would have done that first. So the first thing I do, and I think I'll sketch out my first transformation. So this 4 goes to negative 4. This 2 goes to negative 2. This 4 goes to negative 4, and this 2 goes to negative 2. So it's kind of like I have an intermediary transformation. So that's like my first one. That's the negative one. And then after that, then it shifts up. So it's a series of two transformations. Okay. For this problem, I need to figure out f of negative 15. Where is that? Where is negative 15? It's less than negative 10, so I put it in this first equation. And I get a value of negative 50. And then this next value too, that happens right in this one because this is included. So I would do 2 squared plus 4. 2 squared is 4 plus 4 is 8. And there's my answer. For this next problem, oh, and I realized I made a mistake. I plugged it in correctly, but then I didn't add correctly because it has an open circle. So since it's an open circle, there are two twos. This one is a closed circle. This one is an open circle. So it has to be, sorry, it says negative 10. Sorry, the open circle, sorry, the open circle is at this one. This one has a closed circle at negative 10. This one has an open circle at negative 10. That's why I use this function. So I have negative 10 squared plus 4. Negative 10 squared is positive 100. And then adding 4, this is 104. So when is it increasing? So I have a line. This one's increasing the whole way. This is a parabola, and the vertex is 0, 4. So it's increasing from 0 on up. And then this one is decreasing. So I have two intervals. And this one ends, right? It's going up and then it ends at x equals negative 10. So I have increasing from negative infinity to negative 10. And then for this other one, this one is increasing after 0 and then it stops at 2. So from 0 to 2, it's increasing. Finally, this last one, I got this table. And if I check the table, this is all it goes decreasing by 10, then increasing by 10. And on the other side, constant 3 the whole time. So the first part of the graph has a slope of negative 10. The second part of the graph has a slope of positive 10 over 3. I didn't say 10 over 3, I meant 10 over 3. The vertex is here at 220. So my A is 10 over 3. This is an absolute value function because it's got a V shape. And it's x minus 2 plus 20 because my vertex is 220. All right, I hope this helped everybody.